Yes, you saw that right. We have over 9,000 devices on our home network. And let me tell you this, it's a disaster. There's no organisation, there's no control, there's no management. It's a shit show. And let me tell you how you can avoid it and what went wrong. So let's take it back. Here you go. Here is the core and networky stuff. This is all the Unifi stuff coming out of the Unifi controller that you can see. Let's draw how this is set up in Excalibur so that you can understand better about my network topology. Let's say the network comes in here. Coming into the network, we then have a switch. Switches will be indicated by this diamond. This is the public switch. It's not publicly accessible in terms of management, but it handles all of the public networking. So we, at this house, have quite a lot of static IP addresses. I'm not going to tell you how many, because I think that should be kept private. But we have a large stack of public IP addresses coming from our internet service provider. And out of that, we go to 3 separate systems. So we're going to indicate network switches by USG. We go to the USG. This is the Unifi Security Gateway. That handles a lot of our network traffic. So arrow. We go to the USG. Also coming out of that, we've got, let's just copy it. Oh. We also then have the Edge router. This is another Unifi product. We have one of these, which handles a lot of our core servers and systems that are publicly exposed to the internet. We also have the VPN endpoints. I just call that VPN. This is essentially a server that's publicly exposed to the internet, which has got firewall rules on it, and is the VPN termination. This is how we can remote back to our house and any other properties that we have. This is where they all connect to. So we have some off-site locations which we'll get into. They all come back to the VPN server and then access the internet on as if they're from our premises. So as you can see, there are 3 things. So we also do have some more. We have another server that's publicly accessible on the internet. This holds some of the core web servicey stuff. It's all firewalled out, so it's very secure, and local, and all the management happens only over the local network. But it is technically publicly accessible. That's just a few of our core services. We also have some other stuff that is available, but I think for this demonstration, it's all you're going to need to know about. So let's break out how each of these networks works and how we get to 9,000 clients. So coming out of the USG, we got some switches. So let's just layer them. We've got what I call 3 core switches. We've got the AP switch, the CCTV, what is our Netgear switch, but what we call the servers/client network. So that's the core infrastructure that you've seen in other videos that's upstairs in the server rack. Elsewhere in the property, we have the secondary server switch. That's located in the garage along with our new 2 USGs. These are running as servers. We also have our hot tub switch. So over by the hot tub, we have some core things like projectors, Sonos, Apple TVs, and in the UK, something called SkyQ. They're all over located by the hot tub. So we have a single line and they're all on different VLANs. So that's over there. We also have a back garden CCTV switch. So that's kind of over in that direction for me. But essentially, because our back garden is so long, we have a run of fibre running from the network switch over round the garden over there, where we have a distribution switch for about 5 or 6 CCTV cameras that are located in that corner of the premises. This works quite well. We don't do much with it. It's just a Netgear, simple, managed switch, just doing a few VLANs. I never change the config. Nothing ever happens over there. But let's link this all up and I'll show you how it all links together. So coming out of the USG, we go to the AP switch first. We then come out of the AP switch and go there. And we also come out of the AP switch and go to the secondary switch. Also coming out of the AP switch, we go to the hot tub. The AP switch stands for access point. That's what does all of our Unifi access points. what do we have? I think we have 8 access points on this location. We also have another location which has another 2 access points. They're all managed in the Unifi controller, and that's quite good. It's quite centralized, very simple. I love the Unifi controller. That's one of the key aspects of Unifi I like. I'll admit I'm having some problems with the hardware. We have a massive network. It doesn't run very well on a Unix server, on a Linux server that we've got, but I might get in some kit, hopefully. Coming out of the CCTV switch, we go to all the CCTV cameras. So let me just draw them in here. Let's put them in this colour. We have 40 plus CCTV. On this premises alone, we have over 40 CCTV cameras. It's one hell of a network. That consists of, they're all USG G3s, G4s, G5, and some flexes. That includes all our internal CCTV as well as our external CCTV. There will be a video coming about that soon if you're interested. If you've got any questions about it. We're using Unifi Protect. We've got an NVR and stuff like that. It all works quite well. To be honest, I'm happy with it. I do have some bugs. We're having some bugs recently, but I think overall it's quite good. What's going on with the server client switch? This connects to the AP switch. We'll come out of here like that. As well, this is where we have most of our clients. It's most of the wired clients, which consists of most of the network. We have a lot of Sonos speakers, somewhere in the range of 100 to 150 Sonos speakers. They're all wired in. They're hardwired via network cable into the network switch. They go to the CCTV switch. This is a 48 port switch. Not all of the Sonoses are wired though. They're using their bridge technology, but most of the core ones are wired. Like the 2 that I'm looking at here, they're not wired. But that's what's on there. But also on this server client switch is where all the edge router networking links go. So we have it VLAN out. We also go into this CCTV client switch. This then feeds, so let's draw this out. So we had, what did we have? We had 150 Sonos, 40 CCTV. Coming out of this client server switch, it communicates with the servers. So we've got what I would call the main server, the secondary server which runs some MDM and stuff like that, some of our management stuff. We have our database server. These are all running locally upstairs. We have our VPN server, which I've talked about already. So there's 4 servers. What else have we got? We've got the Grafana logging system, so that has its own dedicated server. Then we also have a few Raspberry Pis, about 4 Raspberry Pis. So we have about 9 clients, 9 servers. So let's indicate that here. 9. We have 9 servers on the network. I've tidied the graph up slightly just so it's a bit easier to read. 40 CCTV, 150 Sonos, 9 servers that I just listed. What else do we have? What consists of the core network? So we have other systems such as Unifi Protect NVR, Unifi Network Controller. We also have some AI devices. These aren't really servers, but they're miscellaneous compute systems. I'm just going to put that down. So got about 10 or so other compute. That consists of those sort of devices as well as some other stuff that we have that maybe doesn't quite make a mention in this video. Coming away from that, we've got some smart home devices. So we've got a Habitat hub, 2 Hue bridges, an IKEA hub for our blinds. We then have some Wi-Fi connected devices, but let's put the hubs in first. So smart home hubs. We've got about 5 or so of them. Yeah. We then have Wi-Fi connected smart home devices. So this is going to be stuff that I've bought that's connected to the Wi-Fi. So we've got about 5 or 6 of those light panels by Aurora. We've got some Nest smoke detectors, stuff like that. That's about all I can remember off the top of my head. So that's about 8. Let's call that 8 Wi-Fi smart devices. We've got about 8 Wi-Fi smart devices. This is kind of I'm just breaking it down for you to understand what's on the network. So I've built some custom smart home technology with Node MCUs. I haven't got one handy, but we've got some Node MCUs. We've got quite a lot of these. So every room's got about 4 Node MCUs. Motion on one, temperature and humidity on another. We're doing some clever presence detection on some other. on others using millimeter wave, stuff like that. And then there's just a general output controller to control lights and custom accessories in that room. So if every room's got about 4 or so of these, we've got got about 20 or so rooms, so we've got about 400 node MCU. They make up a lot of the core Wi-Fi stuff, so they connect to the Wi-Fi and they reboot if they've got any problems and stuff like that, but they do a really good job. And personally, I've found them to be really reliable. I quite enjoy them. They're very easy to tinker with. They're running some Arduino code. We've got a whole CDN pipeline for that to progressively update the code, that sort of stuff. In terms of smart home stuff, that's probably about it. We'll put that there. That's about all the smart home stuff. Now let's get on to the clients, the sort of mobile phones of the network that you may think of. So let's talk about it. So iPhone-wise, so we've got about 35 or so iOS devices. That includes iPhones, Macs, and Apple Watches. That consists of a lot of the core iOS networky stuff. We do have a few Windows computers on the network, but only like 5. As you can see, it's really a Mac house. These kind of consist of the general sort of client-y stuff. We've also got other stuff like over here. I've got what's called an MA lighting desk. It's a Grand MA. It's a massive lighting desk. So we've probably got about another 20 other devices connected to the network. And really, that's probably about it for the core sort of networky sort of stuff. You're probably looking at that and going, that don't add up to 9,000, and it doesn't, because I'm not telling you about all the other stuff we got, because I've not gone into what we've got over there. We've got network switches. I've not talked about the USGs in the garage, some of the other hypervisor servers, some of that stuff. But I just wanted to give you a kind of brief overview of what's going on the network. Now let's talk about how it's segmented. So I can scroll over here. It's all segmented by VLAN. I'll draw the VLANs out. So I've just drawn a few columns out. We'll just talk about it. So we've got the main network. This is where all of the sort of main client-y sort of devices happen. Then we've got what we call the USA network. So this is on the 10/10.0.0.0/20, I want to say. Then we have the USA network. This is essentially a VPN network. So over in the US, we have a residential connection to a provider where we're running a VPN to allow us to watch US TV here in the UK. This is our own custom thing that we've set up. That goes via the edge router and the VPN server. But we then distribute that around the network on its own VLANs. This is the 20.0.0.1.0/ That's that network. So that consists of that really consists of the one primary network and then this USA network, which only has really the Apple TVs, which actually we didn't talk about them previously. Coming down from that, we then have the CCTV network. This runs on the 30.0.1.0. This is a locked down network. Essentially, there's no public access, no ability to get to it remotely or any of that sort of stuff. It's literally sealed in its own container. Only stuff locally on that network can access it, and only stuff in that network can access anything else. You can't get out, you can't get in. Then we have the smart home, the SH network. This is the 40.0.1.22. This is a locked down network with internet only. It also has Sonos on it. That's where the Sonos system resides. We're then using some sort of ARP, not ARP, I don't mean ARP, I mean MDNS translation to get Sonos available on the main network, which is where all the iOS devices are. What else do we have? So we will then have the Sky Q. This is the 50.0.1.1. So on the 50 network, we have what is our Sky Q system. Sky Q is a TV distribution thing here. You get like a main box, it has a satellite, and then you get these like mini boxes. They sit around the network. They don't play well with Unifi, so we have to have them on their own VLAN that only goes through the Netgear kit. They all kind of sit in the server room. We do have a few elsewhere in the house, but most of them sit in the server room. That's on a lockdown network with no public internet access, other than the fact they have to talk to Sky servers. There's a init.sky.com that they like to poll in to make sure they're still activated. So we have the main box only allowed to access that endpoint on those IP addresses, on that IP range. That's it. Otherwise, no access to the internet, no access to local devices, anything. It doesn't show up anywhere. We also have, so the server has access to most of these networks. The main core server has IP addresses running on these because we have a mobile app on our phones to allow us to control the TV and part of the smart home. We do have some other networks which I won't get into, such as our TDS only network. This is a network that exists here at this premises, but also exists at our other location. And via VPN, they are one network. So essentially, there's a VPN link. This is a lockdown network with no internet access, just to allow us to put stuff like Amazon Fire tablets that we've got using for smart home, stuff like that on them, that we want to be able to control in different ways. It's not quite like the SH network where there's internet-only access. There's no internet-only access on this network. And it just kind of has all our miscellaneous devices. We also have what is our server-only network. This is a network that resides all the servers and all the server control systems, such as network shares for Samba and stuff like that, all that sort of stuff. All the sort of networky distribution, DNS stuff, all resides on that. So all the servers can talk to each other on a high bandwidth plane. That kind of consists of all of those sort of networky stuff. Let's look at this on Unifi. Let's see what Unifi's showing me. So if we come into Unifi, you can see we've got all our devices. Unifi will hopefully give me a nice topology. There you go. You can kind of see how all the access points come off of the CCTV and stuff. But yeah, if you go to client devices, it says we've got 9,075 devices. I'll just show you a few of them. I won't scroll through it all. I don't want to show you it all. And why is this a disaster then, really? If I'm honest, it's a disaster because what devices go where has become a bit obscure. Like, there are some CCTV cameras on the main network because they're over there on that link, which only got one VLAN over it. Needed to be on the main network to put a device in, like Sonos, and then whatever. So sort of stuff like that. It's just become a bit of a disaster to manage. But overall, actually, it's a very complicated network setup. VPN wise, we have about 4 or 5 VPNs. So we've got what I call our point-to-point link VPN, which is connecting our other remote sites into this. We also have one going to AWS for all of our core infrastructure sitting there. Then we've got personal endpoints so that I can VPN in here. You can VPN to the VPN server. You can also VPN into a backup system, which is not on this graph. We have then about 200 or so websites hosted on web servers that exist here, that aren't in here. All that sort of stuff. There's lots of stuff going on in the network. And if you guys are interested, I can do a deep dive on what technology we're using, all that sort of stuff. But I think I'll wrap this one up here, and we'll call this part 1, because we'll do part 2 of the network, talking about the physical stuff and how it's actually ran. And you can watch that when it comes out soon. But if you've enjoyed this, there's a button specifically for that, and then you can get notified when I do my next video. Enjoy.